welcome to our presentation. My name is Christian, and then we have
Jeran. And I'm Morgan.
Awesome.
I would like to start off by pointing out the obvious. We are in the middle of a pandemic, and as a result, there are massive shortages of PPE, ventilators, toilet paper, all sorts of stuff. Part of our IME 418 product development class, we were tasked with developing some sort of product that would help ameliorate the situation with COVID. And what we ended up thinking was one of the major issues was N95 disposable respirators. These things, the demand for them has increased 4 to 10 times, and the problem is that there's such low supply that the doctors in LA have to use a mask for their entire shift, and in New York they receive one every few days. And that's really not good because these masks break down, they get moist, and they weren't designed to be reusable. The problem with making these masks is that the production of this material is the biggest bottleneck. The machines that make this, there's only a handful of machine manufacturers in the world, and it takes 7 to 9 months of lead time to get this machine. So while manufacturers such as 3M have already doubled their capacity by staffing more and trying to pump things through faster, it'll take a lot longer to get the machines to make more masks. And part of this project, we decided to try to find a medium-term solution until the mask manufacturers will be able to get up to capacity. So we looked into making a 3D printable masks that could be made across the country in people's homes. There's thousands upon thousands of printers throughout the United States. And we looked at existing designs to see how people have approached this problem. What we found is some of the designs were inherently complex, others didn't provide enough protection, and some of them were fairly good. So we started working off this Montana mask design, which was pretty popular, and they posted the files open source, so we were able to go in there and edit it, and based off of testing and feedback that we did at the local hospital, we made a bunch of changes. Now I'll pass it off to Morgan to talk about the improvements we've made to the old design.
Okay, so for our design, we made some modifications. We increased the filter area in the front, as well as added this protective front part to the original design. We also increased the edge right here for better cheek fitting right there. And then we increased the depth on the inside so that it could fit more noses and faces. After doing some research and finding a video, we decided to go with a silicone seal around the edge, like this. We made it by 3D printing a mold with a removable core so that we could put the edge in it. Due to the bottleneck of N95 filter material, we decided to look at an alternative, which was HVAC virus blocking filter, as well as bacteria blocking surgical sheets. We would put the HVAC filter in between both of them and use this impulse heat sealer to seal it at all 4 edges. And this is the finished product.
To assemble the mask, you first take the filter and the insert, you place the filter on top, hold it as best you can with your fingers, and then you just place it inside, and it can be a little bit challenging, but it's okay if it doesn't come out completely straight. It came out okay. And then you just take the protective cap and put it on, and you're ready to go. So the entire mask was designed to be disinfectable, including the latex-free rubber bands and clips. As for the filter material, this can be used once every 5 days. This means that you can use it once for 24 hours and then put it aside, leave it for 5 days, and after then the virus should be killed off, considering virus dies within 3 to 5 days on soft materials. Once you have the filter material in place and the protective cap on, go ahead and put it on your nose and take the rubber bands, wrap them around, and clip them. You can do it. Top and bottom. And make sure that you apply your mask first and then others around you.
Stay safe!